Ashton Taylor, and here's my poster on muscle contractions. There's 5 main steps, and then there's a billion steps within the 5 steps. So the first step is excitation, and kind of just drew a picture of what it is, but your action potential comes from your nerves and enters the axon terminal, and then inside of this there's little calcium ions floating around. The calcium ions will go through the voltage gated calcium ion channel, and whenever they enter through here, they'll get into these little synaptic vessels. Inside of here, there's what you call your ACH molecules. They'll go through it and they exit through exocytosis, and the ACH then go into your synaptic cleft, and in the synaptic cleft that's attached to your sarcolemma, there's more ingraded ion channels, and through here then your sodium will exit through, and there's little ACH receptors on there, and that's what opens and closes the channel. And all of these ligated ion channels are ran along the sarcolemma, and this together makes up your motor end plate. Once you go through all this, then this will enter into your cytosol of your muscle fiber. And a big thing about this is when they go through this gated channel down here on the sarcolemma, it becomes a little bit depolarized. So, and it kind of goes as a wave. So here, this little section's depolarized, and it keeps going, and this little section depolarized, and then it keeps going, and so forth. So that's the first step. The next step is your excitation contraction coupling. And this is kind of a big picture once again. So it comes straight from here, and down here's your sarcolemma, so just follow with me. This continues to be your sarcolemma over here. And that's where your action potential starts. The end plate is moved up here, and that starts your action potential. It's going to come down your T-tubule, and while it comes down here, the ions depolarize. Once it comes down here, your little calcium ions will go through, and they hit your calcium ion channels. Once again, they open and close. And then once they come through here, and they'll come back up, again, that's your sarcolemma, and then you're into your cytosol, which is all this ECF per se. The third step is preparation for contraction. It's a little hard to read, but I posted pictures. So this is going to deal with your thin filaments of your muscle fibers and your thick filaments of your muscle fibers. Your thin filaments are composed of your troponin, which is like a little bitty, I'm marked it as red, but it's little bitty things, and that is what, I don't remember what I was saying. And then your tropomyosin. On your tropomyosin is where your active sites are, your actin active sites are, and I'll show them as a little hole here. And then your myosin head, which comes up from that thick filament. Once the contraction actually starts, it's broke down into 4 steps. So here you have your active sites on your tropomyosin, and this is where it all kind of starts. And your before anything can connect here or attach per se, your myosin head is going to cock back. So it's going to come back just a little bit. And your ATP is what gives the energy to like kind of kick it out. And then once you come down to the next step, your myosin head is it bends a little bit more. It binds to the actin at a 90-degree angle, which here it's attached to your tropomyosin. The next one is what they call a power stroke, because that's where it actually flings and that's where it hits. And your myosin head is going to be attached now to the myosin, and it's going to be about a 45-degree angle, and your ADP and your phosphorus is what's going to come out from that once your ATP helps. The following step is the ending of the contraction. And on this, your ATP is what ends up breaking away that actin site and your myosin head. So now it's a thin filament and a thick filament once again. And this whole thing is kind of grouped together as what they call a cross bridge cycle. So once this breaks, it's going to repeat. And it's just continuously going to do that for like 30, 40 times until like your nerves say, okay, stop. And then the final part of your muscle contraction is when your muscle finally relaxes. And this is more or less a big picture of all this summed up. So whenever you first start, you're going to have your action potential coming here, and then your calcium ions go through and attach the symptomatic vessel. Inside these vessels are ACH. Your ACH is going to go out through exocytosis, come down into your symptomatic cleft, and then go through these gated channels once again. And also your calcium goes through a gated channel, don't forget about that. So there's 2 gated channels in this little section. Whenever it comes down, your ACH is going to get kicked out. And once again, this is happening along the sarcolemma and inside the symptomatic cleft. It's going to come down and be repolarized along that sarcolemma. Once it's repolarized, that is considered your active potential of your muscle relaxation. There's another voltage gate. This is going to be your potassium voltage gate, and they're going to open up and let the potassium come through. And then it's going to come, once again, it's going to come down your T-tubule, and then it's going to go, your calcium ions are going to be down here. Your calcium ions go through another calcium ion voltage gate, and they're going to go into your sarcoplasmic reticulum, which is this little section, and then your T-tubule, and then another sarcoplasmic reticulum. And then they're going to come up along your sarcolemma and inside your cytosol. Now, at the bottom of your T-tubule and your sarcoplasmic reticulum, there's your thick filament and your thin filament. And then that's where your active sites are going to be blocked. The tropomine is not going to is going to close your tropomyosin off, so therefore the tropomyosin cannot, or the block sites on your tropomyosin is closed, so no myosin heads can come up and attach to that. And then the other thing that I did forget to say, once your sarcolemma is down here and your muscles relax, they're gonna be considered at a resting membrane potential, which basically means they're gonna cut off these channels to where no calcium can get in. It's just kind of chilling. And then that is a complete muscle contraction, and it's going to stay at rest until a nerve is told to contract the next muscle.